Ready?
Recording is started. Go ahead, Sue.
Hi, my name is Sue Miller. I'm the Executive Director of Darby Creek Valley Association. Welcome to our Watershed 101, our Salt Watch, Lunch with Lauren, our Winter-Summer Salt Watch program. We have the pleasure of having Samantha Briggs and Emily Biowas from Isaac Walton League. I want to thank you for being here, and also one of our presenters, Kevin Roth from the video, is also on today. I'm going to first introduce Lauren, and then we're going to watch a video, and at the end we'll have plenty of room for questions, and we have 4 people that can answer your questions for us. Lauren?
All right, great. So Sue, do you mind to stop sharing? Because I have a little bit of a presentation to introduce some of these concepts. Awesome.
All right.
All right, so my name is Lauren McGrath, and I am the Director of the Watershed Protection Program at Willistown Conservation Trust. So if this is your first time participating in one of these Watershed 101 webinars, I would like to first say welcome, and I'm going to introduce to you why we're having these webinars in the first place. So we are working as a collaborative, Darby Creek Valley Association, Stroud Water Research Center, and Willistown Conservation Trust to get a better understanding of the health of the Darby Creek watershed. So we are working to establish a monitoring program in the headwaters of the Darby Creek. And we have identified 10 different sites where we would like to start doing monitoring. But you know, this is a pretty big project and we can't do it by ourselves. So our goal is to create a community-based citizen science project where we all go out on a monthly basis and collect different samples at each of the sites. And we're going to be looking at a number of different data points, including temperature, pH, salinity, depth, and conductivity. And our goal is to provide all of the necessary training and equipment to our volunteers so that we can go out and skillfully collect all of the samples and the data to get a better understanding of the health of our waterways. So, one of the major components that we have questions about is salinity, which is what brings us to today's Summer-Winter Salt Watch presentation. And I really want to acknowledge and thank the Isaac Walton League of America for allowing us to use their Winter Salt Watch model. It's an incredibly comprehensive and thoughtful project that they've rolled out with great success. And the Isaac Walton League of America is also allowing us to present a pre-recorded presentation featuring Dr. John Jackson from the Stroud Water Research Center and Kevin Roth, who's the Education and Outreach Coordinator at Pennypack Ecological Restoration Trust. And Dr. Jackson's going to get into a lot of the science about how our salt use on land is really impacting our water quality. And then Kevin is going to outline the incredible project that Pennypack has rolled out and how they are getting really incredible engagement from their communities and how they're making a large impact in their watershed, with the goal that we're going to be looking at this salt and chloride levels in our stream throughout the year. So extending it beyond just the winter salt watch and looking every month to see how the salt that's contained in our soils, on our lawns, washing in from the roads, how it's continually impacting the health of the headwaters of the Darby Creek. So with that, I really want to say thank you for tuning in this afternoon. And if you have any questions, I'd like to reiterate what Sue said. Please enter it into the chat function. And if you're interested in getting more involved with the I know it was a very brief description of our monitoring project, there is going to be contact information presented at the end of the talk. So please reach out to us if you want to get more involved in the work that we are all doing. So with that, I'd like to turn it over to the excellent Salt in the Water, Action on the Ground presentation by the Isaac Walton Foundation. Which, Dave, I think you have. Right?
Going to turn things over to Emily. First, this webinar is being recorded and it will be available on the Isaac Walton League YouTube channel soon. Keep an eye on our website at iwla.org for information about the recordings of our past webinars and for the upcoming webinars in our series. Second, if you have a question during this presentation, you can type it and send it from the GoToWebinar chat box. We're going to have time for Q&A at the end of the presentation, and the webinar should run about an hour, though we can stay on for a few minutes in case there are any extra questions at the end. All right, with that, I'm going to turn things over to Emily Bialis, the Chesapeake Monitoring Outreach Coordinator for the Isaac Walton League of America.
Thanks, Rebecca. So I'm so glad everyone can join us today to talk about salt as an issue and the actions that we're taking on the ground. So we're so lucky to have two folks with us today to talk about these issues. First up, we have Dr. John Jackson of the Stroud Water Research Center, who's done a lot of work on the impact of salt on aquatic macroinvertebrates. And then we're gonna hand it over to Kevin Rock, who's the Education and Outreach Coordinator for the Pennypack Ecological Restoration Trust in Philadelphia, and hear about how they're using the Salt Watch program in their area and what work their volunteers are doing on the ground. So John is going to start us off and we'll see where it takes us. And as Rebecca said, please put your questions in the question box and we can ask John and Kevin our questions at the end of the presentation. Take it away, John.
All right, thank you. So thank you all for taking some time out. You guys, I'm sure, are busy at home doing things that you should be doing at the office. What I'm going to do today is describe the salt issue, describe some of what we know about it, and describe a bit about how we should approach it in the future. First, I want to just go over the idea of salt, and I apologize right now, I mix terms, and so I wanted to show you these just so you get an idea. They're all related. Whether we're talking about salinity as parts per million or total dissolved solids, conductivity is microsiemens per centimeter, salt as all salt, sodium chloride, or in many cases, people are still referring to chloride as just a measure of salt. All of these are applicable. All of them are related. They're not all identical. The other thing I would like to remind people of when we talk about salt, the salt has an anion and a cation easily dissolved in water, sodium chloride. Sodium is the cation, the positively charged ion, and anion, the chloride is the anion. And so that's all of these salts that we talk about today are composed that way, and in water they dissociate, they separate. And it's important to know that right now the research is focusing more on the cation, the sodium, the calcium, or the magnesium, than on the anion. And that's new science. In the end, what I want you to walk away with is the idea that salt is a contaminant of emerging concern. The toxicity depends on the stream type, in other words, hardness. It depends on the duration of the exposure, and it depends on water temperature. So all of these things mean that on your landscape, you need to know about your stream. The increase that we've seen in salt is real. and it reflects a variety of concerns of surrounding safety, the economy, business, and also societal and political concerns. And finally, increased salt has generally not been considered, increased salt use hasn't considered things like human health, infrastructure, or environmental impacts. It just hasn't been part of the conversation, but it is increasingly becoming part of the conversation. And when I talk about something as an emerging contaminant, I just mean that the concern is new and we need more information. And that's true for your pharmaceuticals, your personal care products, the things you tend to think about. But this is also true for something like salts from road salt and brining. The good news, though, is we know a lot more about salt as a pollutant than we know about some of these other emerging contaminants, because those are actually new to science. We have done nothing with them, whereas we have done at least some work on the impact of salt on aquatic organisms. Now, salt and the salinization of fresh water is a new issue, and it's also a worldwide issue. Whereas today we'll primarily talk about salt as road runoff in an urban setting, there are areas of the world where agriculture increases salt, where mining can increase salt, where oil and gas development with brine waters can increase salt. So whether you're in an urban area or not, there are possibilities that in your region, there are increased salt issues. This is a graph I use to just illustrate how much salt we're using today. It starts in 1940 and ends around 2005. We see that there was a gradual increase by the time the Clean Water Act was signed. We were now using far more salt than, say, our grandparents might have seen or our great-grandparents. This was developing at the Clean Water Act, but it was so new that the Clean Water Act there were no regs being tossed out about regulating or limiting salt or chloride or anything like that. It was still a new issue. Somewhere in the mid-90s, we saw another jump up, and some people in my area in southeastern PA would suggest that maybe we've seen another jump up in the 2000s. That salt, because it's not biologically reactive, we don't really absorb a lot of it. The sodium and the chloride that's involved with rock salt ended up going into our waterways right away. This is one of the early studies published showing the increase in salt concentration as sodium and chloride in the Schuylkill River at Philadelphia. This was collected at the water intake, one of the water intakes for the city of Philadelphia. And between 1973 and 99, we see that sodium and chloride doubled in that time frame. Since this study has come out, we've seen this increase in a number of other studies, number of different streams, both in the United States as well as in other countries, where road salt has played an increasing role in winter maintenance. When we talk about salt and when people are measuring salt, quite often they focus on the winter because that's when you see it on the ground. But what we're seeing is actually there are these big winter spikes. This is a small stream near Wilmington, Delaware, just a single year in 2017, 2018, and you can see the winter spikes. Now this is a 96-hour running average, so the big spikes have been removed where it goes well over 40%. But background is far lower. In 1,000, the conductivity might be 1,000, might be 1,500 in September, October, November. Obviously, that's still a lot of chloride if that's what you're registering at, or if that's what you think in terms of. This is an idea of where we're seeing these massive increases. It's really in the upper Midwest and also in the Northeast and the Mid-Atlantic. The drinking water concerns are real. This was a small study that was done in New York looking at well water. Over 900 wells where over half of them exceeded the low sodium standard on people with sodium restricted diets, and 10% exceeded the 250 milligrams of fluoride per liter, which is the drinking water standard for taste. I would guess that for at least 15 years, we've known that there was a correlation between stream degradation and conductivity or salt concentration. These are some data I had from 10 years ago, showing that on the upper left are your best streams and they have low conductivity. And on the lower right, as conductivity goes up, we see that there is degradation or it's associated with our more degraded streams. The y-axis is your macroinvertebrate score, where 20 is a great stream and 0 is a very poor stream. So this correlation is been commonly observed, but it's really important that correlation doesn't equal causation. Keep that in mind. You can find a correlation like this. It doesn't mean that salt's not contributing, but if you think about everything that's in urban runoff, where we're applying all this salt, you have not only salt, but all these oils and metals and sealants and herbicides and insecticides and salt, and anything that's coming out of your wastewater treatment plants could be in that waterway also. So be aware that you may have elevated salt, but you also have a lot of other things that are probably elevated too. And be careful about being too focused on salt and missing the forest for the trees. Now, in the science that we've worked on, we've asked questions about factors that are important in terms of determining salt toxicity. We looked at the age of the animal, the duration of the exposure, the stream type, in other words, hardness. Is it a soft water stream or is it a hard water stream? The different species that we could bring into the lab, and also temperature, because remember, there's a big difference in stream temperature between winter versus summer. All 5 factors were important. We found a significant effect on all of these. So it matters. Younger, more sensitive than older. Duration makes a difference. Longer is worse. Softer is more sensitive. Species depends on what you're testing. And toxicity is greater at warmer temperatures. So let's work our way through that. Duration of exposure. This is really a question of chronic versus acute. And that would be, in my case, a 30-day test versus a 2 or 4-day test. And this is the impact. It takes a lot more salt to kill things quickly. So this is for a mayfly, and it took, say, 2,500. If you exposed it instead of 2 days to 30 days, the amount of salt it takes to kill half, so the LC50 is a lethal concentration to kill half of the individuals. This is not, therefore, a protective layer level, but rather really a toxic level. You were killing half the individuals in 30 days at a level that's 75% lower than what a 2-day exposure might require. Hardness is important. Hardness varies depending on your underlying geology. It varies north to south, east to west. It really just depends on your geology, and it can even vary within your state or even locally. We have streams around here that are hard or moderately hard, and we have others that are relatively soft. Hardness, in other words, the amount of non-sodium, non-chloride, these would be limestone versus non-limestone streams. Limestone versus freestone is the way some fishermen might refer to it as, makes a big difference. So these were 3 different streams where we started on the left with a moderately hard stream and going on to the right, a very soft water stream. And the amount of salt that it took to kill half of our mayflies, again in a 30-day exposure, went from 600 to less than 100. So we reduced it significantly we increased the toxicity by reducing hardness. So if you're working in a soft water system, salt is more toxic than it is in a moderately hard system. So then we asked a question about temperature. In the lab, we generally work at a very standard lab temperature, like 20 degrees centigrade. But in the field, your stream can go from 0 to 20 and back to 0 as you go from winter to summer and then back to winter. So what does that do to this toxicity? So these are toxicity results, again, for a single mayfly, where we ranged, we tested temperatures from 5 to 25 degrees. 25 would be quite warm for a small stream in this region. Other parts of the country, it wouldn't be. And 5 would be a winter temperature. Toxicity increases as you increase temperature. That's a well-known phenomenon, but it's really, for salt, so important. So it means that the winter spikes that we observe are less toxic than they might have been if they occurred at summer temperatures. On the flip side, it means that salt that we're observing in the stream in the summer may be more toxic than we originally thought. We thought, oh, it's elevated, but it's not like the winter. So these are how I would summarize it. Toxicity increases with duration. It decreases with an increase in hardness. And toxicity of salt, sodium chloride, increases with temperature. So I'm always asked, so what's our target? What's our goal? Where should we be? How do we know if we have a problem? And that's evolving. So do not take these numbers as being definitive. I just grabbed them out of some of the work that we have done. So I'm qualifying this as being in moderately hard water at 20 degrees. The range we see for chlorides, that would be toxic, not protective therefore, but toxic. If you're seeing somewhere between 300 and 3,000 for an acute, a 96-hour average, for chloride milligrams per liter, that might be considered toxic for those mayflies in that stream. Chronic, it's going to be significantly lower because it's that lower exposure. If you're in the order of 150 to 900 milligrams per liter, you're going to be looking at a potential toxic effect. You can flip those to conductivities and be, in 1,000 to 9,000 for an acute and 550 to almost 3,000 for a chronic. When you're out measuring base flow in the summer and you see 1,000, 1,500, that's going to possibly be toxic to mayflies in that stream. So why has salt increased? This is a really important conversation that people need to understand. It was done for the best of intentions, where there was discussions about safety, economics, expectations by the public, and then the politics tied to that. There were studies done that showed that salt reduced accidents, some 50% up to 90% reduction in accidents. It's more complicated than that, but it was a very strong message, safety. It was also an economic message. When you can't get to work on time, you miss work, travel is slower, you have a reduction in production, productivity, work products, and that translates into billions of dollars for a single storm. I found a quote somewhere that said, salt applications paid for themselves within an hour. The economics were an important consideration. Then we had the public and political expectations about clear roads, where the people wanted convenience. They voted for convenience, that there was a response to what's the difference between being passable versus being clear. Those were things that drove salt, an increase in salt. But now we're seeing a change in the discussion a bit, where now people are expressing concerns about health and taste, concerns about infrastructure, and then the aquatic life toxicity, the mayflies being unable to tolerate the salt that's now in our urban waterways. Let's go through those quickly. Salt is a drinking water concern. This could come from a perspective of sodium if you're on a low sodium diet, or even in some cases, it's just well above the standard in groundwater, in well water. It depends on where you're at in proximity to salt sources. The whole discussion about Flint water had to do with lead. but the mobilization of that lead was tied to elevated chlorides in the water as it hit the pipes. Those elevated salts came from road salt applications, winter de-icing. There's also now concerns about infrastructure and property, private property. So this is a public and personal property issue where we're seeing damage that we got used to not seeing. For example, you now see rust on vehicles that was more common in the 70s and 80s than it was in the 90s and early 2000s. You can see damage to concrete, damage to metal. Those damages are real, and they're working actively right now trying to understand about aging of property tied to salt. And finally, the aquatic life. As I showed you before, these are some data that are right here near Westchester, Pennsylvania, where I live. That was collected by a student working nearby, 5 different streams, 5 different levels, but these are data from September. Road salt hasn't been applied for months. Yet if you look at it, the conductivities are ranging from 600 to 1600. Chlorides are ranging, therefore, between 150 to over 400 in the late summer when temperatures are warmest. Some of these are going to be chronically toxic to some species. We didn't really know about this 10 and 20 years ago, and that means we didn't really take salt consider it as part of the discussion. So now the discussion is going to be more balanced. We have to consider public safety. We have to consider economic impacts of storms. But we also need to think about aquatic life. We need to think about the infrastructure, and we need to think about drinking water standards, because salt doesn't go away. Every year we apply more, we will continue to see an increase in the salts that we have in our waterway. And the conversation is one that's going to be occurring at state level, at the municipal level, and also at private property levels. So to wrap it around, salt, sodium chloride in this case due to de-icing, is a new problem. It's one we didn't think about 30, 40, 50 years ago, but it's only a problem in some streams. These animals can tolerate a fair bit of salt. So I wouldn't say all streams or even most streams, but some streams definitely can have a salt issue. Increased salt reflects the best of intention. We paid for this. It was part of our budgets. We asked for it as a group, as the public. And finally, the negative impacts of increased salt will not be easily resolved. And the reason why is our lives at this point, we're addicted to what road salt provides in terms of ease of access and mobility during the worst of weather. So thank you for your time. I'll stick around to the end to answer questions.
Thank you so much, John. Yeah, so if you've asked a question, we're going to wait until after Kevin's presentation to answer these questions. So now I'm passing it over to Kevin Roth, who is also based in Pennsylvania. We have a very Pennsylvania salt focus today. And he's going to tell us about how their organization is working on this issue in their area.
Okay, can you see my screen and hear me? Good. Okay, my name is Kevin Roth. I work at the Pennypack Ecological Restoration Trust. I'm the Education and Outreach Coordinator. The Pennypack Trust is located in Montgomery County, Pennsylvania, specifically Huntington Valley. We are an 852-acre nature preserve. We protect 4 miles of the Pennypack Creek. We have nesting bald eagles, we have beavers, we have mink, and we have one of the most diverse bird populations in Montgomery County. So you might have heard of Pennypack Creek. It does end up in Philadelphia in Pennypack Park, but we're the Montgomery County section of the Pennypack Creek. So Winter Salt Watch, how did we get involved, and what made us care about this? So there was a snowstorm in November of 2016. November 16th, 2018, And it was a surprise snowstorm that nobody saw coming. The roads were not salted by PennDOT or the municipalities. So we were wondering, where did this salt come from? If you look at the chart that's on the PowerPoint here, the top graph shows a normal storm during this time. The water level, which is the blue line, goes up, and the conductivity, which is the red line, goes down. If you look at the chart below that, the water depth increased, but so did the conductivity. So this was that storm I'm talking about on November 16th, where we saw the conductivity go well over 1,600 microsiemens. So we were wondering, the roads weren't salted, but the creek was extremely high in conductivity. Why was that? Where did that salt come from? So we realized this was a chance for education, because we learned this came from residents like you and me, came from strip malls and other local businesses. It did not come from PennDOT or the townships. So we saw that as an educational opportunity. We knew this was an educational opportunity because we already have a group of citizen scientists that we call stream keepers. This is a part of a greater effort in the Philadelphia area called the Delaware River Watershed Initiative, which is funded by the William Penn Foundation. So you can see all of my partners below. The only one that changed there is Wissahickon Valley Watershed Association. They just changed their name to Wissahickon Trails. Apologize, I don't have their new logo on there. But these are our partners. In each of these groups, we all have a group of citizen scientists that we call stream keepers. These stream keepers go out to the creek once a month, go to their respective sites, and they get data on temperature, water flow, things like that. They take pictures and they send it to us, and we keep track of it. So we thought, well, let's find something for salt that can go into this. That's when we stumbled upon the Isaac Walton League of America and their Winter Salt Watch program. It was a free program that we could get involved with, and we reached out to them, and they said we could be involved. So we created a training session similar to the one you're seeing today. And yeah, we taught our citizen scientists how to participate in the Winter Salt Watch, and it was highly successful. Our goal was to get on the map in year one and just see, what we can learn from doing the Winter Salt Watch. And it's a nationwide effort. This is a little closer look at the Philadelphia region and how much participation we had in just the first year. And you can see how big of a problem it is. So we had over 55 people, at least in our watersheds, working towards measuring this, and I'll go into how they got the data a little bit later on. But you can see the Philadelphia area has a problem with parts per million of chloride in the water. And that's one thing we learned from the first year. So what was our goal that first year? Well, we wanted to get on the map and learn more about how salt is affecting our waterways. Our citizen scientists got involved, and they got the data you just saw. But the main thing is the members of the Isaac Walton League and the volunteers that we have are collecting this data that will be used to implement new and better practices. Our data can go to places such as Stroud and John, and they can interpret it and see which creeks have a problem, which ones don't, where is it coming from, and things like that. Just use the data to learn how to implement new and better practices for using salt. Because as John said, we're not going to stop salting. We're addicted to it. So on that note, knowing that no one's going to stop, we want to encourage people to do better. So after that first year, we started a little bit late because we didn't know about the Isaac Walton League until about January. And that's when we trained our citizen scientists, and that's the data that you saw. That was those 55 reports. It was just after January. So we thought we could do better, and we planned ahead and we made a 3-year plan with 3 targets. So number 1, the first year, which is the year we're in, we were shooting for educating the public. We wanted more of the public to understand that salting is a problem and that we can all do something about it. Step 2, in year 2, we're going to target small businesses. Because as you saw, that salt spike came from the public and small businesses, local strip malls, things like that. So that's year 2. In year 3, we're going to shoot for the big picture. We want to get to the townships, the municipalities, PennDOT, and we also want to get into the policy changes and things like that. So I'll touch on that a little bit more. But that's our 3-year plan with our 3 targets. Right now, we're still in year 1. So before I go any further, you're probably asking, what is the Winter Salt Watch and how do you get involved and what do you do? So for most of you listening, what you're going to do is go to the Isaac Walton League of America website, fill out your information, your address, and things like that, and they will send you a clip, an envelope like this with everything that you need inside of it. I'll show you what's in there in a little bit. But after you receive your test strips, we want you to go out and test at least 4 times at the same site, usually during the same snowstorm. So the 4 steps are ahead of you. So the first time you want to go out is before a winter storm, after salt has been applied to roads, and then after the first warm day or rainstorm following that snowstorm. And then the last and final time you want to get out there and test is after the next rain event. So the rain comes, washes all that salt right back into the creek. So how to participate? After you get your envelope from the Isaac Walton League, they will send you everything you need, instructions on how to do it, how to participate, which is the screen you're looking at right now, a little card to take a picture with and pair up your measurement with. And that's everything you need. Your test strips come in a nice little airtight bag, just such as this. So I got everything prepped. So I got my stuff in the mail. I got my test strip. I went to the little pond in front of my house, and I started the winter salt watch. It's pretty simple. All you do is get a clear plastic cup or something like this, go out to your pond or your creek section, fill your cup up 3 times, dump it all 3 times, but then the last time you leave about 1 inch, get your test strip and simply sit it inside. So as that takes its measurement, you'll just wait about 3 minutes, and after the 3 minutes, you're going to get a test strip that looks like this, and it has a nice black line on it. So that means your test strip is done. After you get your test strip done and you have your reading, you line it up with the card that they gave you, and you take a picture. You take a picture of exactly this. So my reading was about 2.8, and on my chart it says 2.8 quantab units equals 76 parts per million. So that's my measurement. So after I get my measurement, you take a look at the screen, and this is how you participate. You download the Water Reporter app to your smartphone, create your personal account. Then you join the Isaac Walton League of America group. Then after you have that picture of yours, you submit your report. You open the Water Reporter app, you click on Start a New Post, you add the photo, and then you enter #SaltWatch so everybody else can see it. It's important that you join the Isaac Walton League group so this actually goes to the map that they're creating. So this is what the final picture looks like when you're sending it into the Water Reporter app. As you can see, I'm out at the creek. I'm at my site. There's snow on the ground. And that was one of my highest readings. That was about 4.8 quantab units, which is 221 parts per million. So I uploaded that to the Water Reporter app, #SaltWatch, so everybody else can see it. And essentially, that's how you do it. If you want more information on that, you can go to the Isaac Walton League of America website where they have videos, pictures, and explain everything. And most importantly, you can sign up for your own test kit that they mail to you. Okay, so like I said, we're on a 3-year plan, and this is the first of the 3-year plan where we're working with homeowners and our stream keepers. So we had kind of 2 avenues we wanted to do it. We wanted to work with our own citizen scientists and have them sign the pledge and do the winter salt watch. But we also had a social media campaign, which I'll touch on in a couple minutes. So you're looking at right now is the pledge. It's our winter salt watch pledge, which has just a little bit of information about, why is salt a threat, who is monitoring, and the other organizations involved. The pledge is pretty simple. We only ask them to do 3 things during this. 1, use all 4 of your road salt test strips and report your findings through the Water Reporter app, which I just showed you. Step 2, share this new knowledge about road salt water pollution with your family, friends, neighbors, anyone who listen. I know I have several volunteers who do it to anyone who will listen. I know Deborah's listening today. She's done a great job. She's one of our best volunteers when it comes to the Winter Salt Watch because she's written letters of support for Winter Salt Watch and educating all the local businesses that she goes to. So that's one example. And 3, just do better at home. We know people are addicted to using salt. We need it to get to work. We need it to stay safe. We understand that. So we ask people just to reduce their salt use at home and seek out safe alternatives when they can. We had over 60 people sign and return this pledge this year. So it was a really good first year. So we used our citizen scientists and our stream keepers to do step one. They're actually in the creek getting these measurements, telling their friends and neighbors. We also wanted to educate the public that, this is an emerging problem. Most people throw as much salt as they want out there and they think it's a good thing, which it is. It keeps people safe. But it also has harmful effects on the environment. So the social media campaign, we called it Stay Fresh, Not Salty. Thank you, Lindsay Blanton from Wissahickon Trails. That's her catchphrase. But fresh water should not be salty. As John said, most aquatic macroinvertebrates and species like trout that live in the water, they can handle a little bit of salt, but not too much. That's why we called it Stay Fresh, Not Salty. We also created a social media toolkit, which has pictures like you see here. We had about 10 pictures, I think, and we stormed in Instagram and Facebook with these pictures from all of our organizations, and hopefully got the message out there that you can do better and you can do better at home. We also created an online pledge, which had a decent amount of signups of people pledging to do better at home. So our goal was to get the message out and educate people that this was a problem. Our local impact was actually pretty large. We were front page of Philadelphia Inquirer. We got an interview on KYW radio. And recently we got a full spread on Grid magazine. So year one, I say it was a success, even though it barely snowed at all. We didn't get too much snow, so there wasn't that much salt in the roads, which is a good thing. But year one was pretty successful. Like I said, the Philadelphia Inquirer, KYW, and Grid magazine. You can check out our website to see most of those. It got the message out, and that was the main thing we wanted from this, is people to do better and get the message out that salt is a problem and we can do better at home. Just a few facts for people listening at home. This is the things that we try to teach people, our citizen scientists and the community. For examples, our salt just doesn't disappear after a storm event. Any excess salt that doesn't melt away, it's still sitting there on your driveway. The next slide will show you some tips for handling that. Alternatives, such as beet juice and things like that, they still require salt. So far, all of our alternatives still have a high amount of salt in them. When you are salting, you don't have to feel that crunch for salt to do its job. A lot of the times you'll go to a strip mall and you'll see a blanket of white, and when you're walking, it's crunch, 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 crunch. That's not necessary at all. So you don't need to do that. But the best way to reduce your salt is to talk to your municipality or State Department of Transportation, which is our next year plan. That's our year 2 plan, and year 3 actually. But so that's coming down the way. We're just educating the regular folks like you and I, homeowners and small business owners, to do better. And those are four of the myths when it comes to salting. What can you do? These are other things that we send on our social media and to our stream keepers. And just 4 simple steps. Like I said, we understand that people are addicted to salt. We know it's a good thing. It keeps the road safe, keeps the economy moving. But these are the 4 things that you can do at home that will play a major role in reducing the amount of salt that makes it to the creek. Shovel first. A lot of people think you can just throw salt on snow and it goes away and you're good. That does not happen. If you shovel first and then use salt, that's the best chance you have of reducing the amount of ice that forms, hence the danger. The second thing you can do is reduce, and reuse. This will save you money, and you'll have more to use in the coming years. So after a storm is over and it's nice out and you see a rainstorm coming, the best thing you can do is go back out, sweep up your salt, and save it for later. It still has the same effectiveness if you use it later, and you're not wasting it. And when that rain comes, it's not going to end up in the creek anymore. Another thing you can do is, if you are going to try alternatives, read the label. Don't be putting anything worse than salt into the creek. So make sure you read the label. Make sure you're not polluting the creek any more than is already happening. And speak up. This is one of the main things we want everyone to do. Is you can't care about something until you know it's a problem. So tell your friends, tell your neighbors. If you see an unprotected pile of salt in the middle of a parking lot, find out who owns that parking lot and just talk to them. Don't bring the pitchfork and get all angry. Go talk to them and educate them. A lot of this comes from ignorance. People just don't know. So the best thing you can do is educate the people around you. So like as John was saying, this is not just a winter problem. We call it the Winter Salt Watch, and that is our current campaign. But as we're learning, it's not just salt we put down in the winter. It's also chemicals that you use in your garden, washing your car in your driveway, fertilizer in your yard. A lot of those other things also contain salt, and when you're using them, that also goes to the creek. So we're learning that this isn't just a winter problem, but that's just the program we're at now. Like I said, we're in year 2 as a group doing this. So far, it's been highly successful, but we're getting the results we want. More publicity and more science to back it up and to tell us how to do better and what we can do. So thanks for listening. If you want to get involved in the Winter Salt Watch, it's really easy to do. All you have to do is go to the Isaac Walton League of America website, click the Winter Salt Watch tab, read more information, and if you're still interested, you sign up and they will send you the test kit that I showed you right in the mail, and it gets there very soon. And it's free. There's a free way to participate and become a citizen scientist.
Hello. I'm not sure if anyone can see me right now. I'm working on having some computer issues. So if you can just bear with me. I want to thank everyone who joined us today. Unfortunately, we lost Lauren due to an electrical power outage. So if you bear with me for a couple seconds, I will get some information up. So, like I said, Lauren lost her power, so I'm going to finish up. Unfortunately, I don't have the rest of the presentation, but on your screen, you'll see that these are the contact information for us. If you have if you want to volunteer, we are encouraging everyone in our Watershed to join the Isaac Walton League Salt Watch program. And we will be conducting our own Salt Watch as our monitoring program picks up, along with our other citizen scientists and stream watch programs. And this will be available, video will be available for further reference. I'll email it to you. I am looking for the chat screen, and we have a couple questions, so I'm just going to read them off. Okay.
Sue, this is Dave. I was kind of monitoring the questions as the presentation was going on.
Okay.
I can catch you up if you want. The first question was from Henry Bryans, and I think it's going to be a good question for Kevin Roth to answer. So Kevin, while I'm reading this, you might take your speaker off of mute. But Henry asks, we live on Paper Mill Road, which is on Pennypack Creek, which parallels the creek. We have about 1,000 feet.
It's, Dave, it's in Newtown Square. It's on Paper Mill Road. It's actually the Darby Creek.
Oh, geez, excuse me.
That's okay.
I was thinking of Paper Mill on Pennypack Creek.
Okay, no, there's actually one in Newtown Square. And there's, okay, but I mean, Kevin still might be able to answer the question. Are there better alternatives that the township could use to lessen the salt? I don't know, Kevin, do you want to answer that?
No, I don't know is the short answer. For the township, no, they're going to continue using what they use. Next year, like I said, year 2 is when we're working on the municipal level of things. So yeah, at the moment, no, I don't know.
That ties into a question a little bit later, which is about on a more personal level of what non-salt deicers are available. I did post in a paper from the Carey Institute that identifies some non-salt deicers, but I know, Kevin, you mentioned some in your presentation, so I don't know if you want to specifically talk about any of those. Or Emily. And I think Kevin may be having connection issues.
Yeah.
So I was just going to say that the focus for de-icing is less on the no salt and more about using it really efficiently and economically, and that you can do things like sweep up extra salt after to be used again. And that doing mechanical removal of snow is a lot more effective and lets you use a lot less salt. If you're just sprinkling salt onto already fallen snow, that's not going to do anything. That's going to take a lot of salt to remove the snow. And a lot of our messaging is about, doing shoveling early and often, and being conscious of how much salt you're using and feeling free to reuse it. There are definitely things like you can use sand, but that also, if you use too much, can have water quality issues. But those are our main recommendations.
Thank you, Emily.
Yeah, and if I may tie that this conversation back to Henry's initial question and the question afterwards about what the municipalities might do. There are actual, Emily mentioned physical removal of the snow and ice, and obviously on your personal property, shovels and snow blowers and stuff are good for that. But there are, for roads, there are a lot more high technology type plows available, for instance, now that they call live edge plows that form a nice direct contact with the roads and more efficiently remove the snow from the roads.
Okay. We also have another question from Lauren. Lorraine. What is the proper covering of a salt pile? I guess the best way to store it would be not out in the open. So I'm not sure, different places use different things. Some people, I've seen tarps being used. I've seen them in shelters. Some of the townships build these like giant barns and store their salt there. So that is the best to my knowledge. And Lorraine also wants to know what chemicals are in non-salt deicers. Does anyone know? David or Emily or Kevin, if Kevin can get back on. Apologize, we're having power issues here, Emily.
That's okay. It's pretty stormy here as well, so
yeah.
I'm expecting power issues later today. The only other thing, if you're concerned about like your township's storage of salt, is that it's also being stored, it's being properly covered and it's being stored away from a waterway. I've definitely seen salt piles right up next to a stream, and that is concerning. I'm not sure about the chemicals in non-salt deicers. Sometimes you'll find that they're alcohols, or you can use like an alcohol to clear ice sometimes. If you're talking about non-sodium chloride deicers. Oftentimes other salts will be sold as some better alternative to classic sodium chloride road salt, but you're still putting down a chloride solution. So that's something to note, like if you're getting potassium chloride or magnesium chloride, that those are still salts and that they still have that negative impact on water quality. Beyond that, I'm not sure.
All right, thank you again, Emily. Once again, I just want to bring up that, DCVA would like to, and Stroud and Willistown would like to encourage people to sign up for the Isaac Walton League Winter Salt Watch program. And we can get the data from them, so go ahead and, upload it to their system. As our program gets rolling out, we are going to be doing summer and winter because we want to get a nice baseline of what's going on in our watershed and when. Because the other thing is, as they mentioned, is that the salts, also come from fertilizer, car washing, and other things like that in the summertime. But the other thing is salt does not disappear. When it goes down, it'll actually go into the soil and then eventually work its way down into the groundwater. And during storms, it'll get flushed out through the groundwater into the stream. So one of our things that we're going to be looking at is what is the salt content, not only in the winter, but throughout the summer. What is a nice baseline for us without a storm event, and the levels after a storm event within the coming weeks too, as the soils and groundwater soak up the salt and get washed out. So if anyone has any questions, I'm sorry, I'm having computer issues. I wasn't ready to present. Lauren was supposed to. So I will send this recording out to you so you can review. If you want to volunteer for our Citizen Science Streamkeeper program, you can email me. I'll put you on the list, and as we get started. But we would like to also encourage you to sign up for the Isaac Walton League Winter Salt Watch program.
Susan, we do still have kits right now that people can still request. I'd say we probably have 50 or so kits left to finish out the season. We have about wrapped up, a lot of the results we get in have been tapering off, but especially due to coronavirus and social distancing, we've been encouraging people, if they want to do some sort of water quality monitoring, to continue to participate in Salt Watch, because you can do that at a distance on your own. And as you mentioned, the chloride data is still very valuable in the summer months. So we value it as we get it as it gets warmer.
Thank you very much. I think that concludes our presentation for today. Thank you again, Emily and the Isaac Walton League, Kevin Roth and David Bresler, and Lauren while she was on. All right, thank you.